Okay, so hello everyone. Thank you very much for joining. My name is Remus Popescu. I am joined here today by my colleague, Bogdan Sava, and we will be talking to you today about open metadata and the BI world. And before we get into the subject, before we start the whole thing, let us say a few words about who we are, how did we end up here today. I'm Remus, and if you were to put a stamp on me, I am the BI part of this presentation. I'm a BI guy, like most of you, I hope. And currently, I'm a BI developer at ING Tech. My world in the BI area was like 7+ years. I've been a reporting specialist, I've been a developer, I even saw the BI world through the project management's eyes. But I've returned to my, let's say, one true love, coding and development, and I'm trying to use that broader view with the help of my colleagues to make my life a bit easier, a bit more automated, and maybe I can give you a few pointers and tricks. And how are we doing that? Well, with the help of internal ING staff, like developers, business analysts, and also with the help of our talented colleagues, like Bogdan over here.
Okay, thank you very much, Remus. I'm Bogdan. I'm a software engineer. I'm with ING Tech since 8 months ago. I used different technology during my career, but most of those years I spent it with Java. I started basically with Java from the first version, from Java 1.0. I think it's something like in late 90s, if I remember correctly. I've worked in many projects. Some of them I started from zero. Some of them I rebuild it, but today I am going to give you a presentation about a cool project that ING is involved in. It's about open metadata, which is an Apache open source project about metadata management, not only about open metadata, but also about virtual data connector. It's another project that incorporates open metadata. And to give you an idea about the agenda, I'll try to get you a bit of a demo about everything. But keep in mind that the project is in a development status. It's not the project is not ready for production yet, so it's more oriented on a couple of functionality. Then Remus will give you a presentation about BI blocks, BI automation, and also a bit of a demo about it, and try to show it how can they benefit out of the open metadata and give you a BI perspective of the things. But first, if you wonder how we get this idea to get this presentation together, I will let Remus to tell you about this idea.
Yeah, well, how do things start in the BI world, and how do things start at a big company? Well, usually everything starts with a request in the form of an email, mostly towards us, the BI people. And our story starts something like the following. And if you would like me to sketch a little bit the email, I would put it like this. We, the business, want you, the BI guys, to enhance one of our reports. And we figured out we have a cool new source out there. It has like 500 tables, but don't worry, we don't want all of them. We made a thorough analysis, and we want only 93 of those. Just be careful. They're differently structured, different columns, packed with information. And P.S., we kind of wanted it as soon as possible. That's kind of the regular email in our world, and everything is urgent, everything needs to happen today, and how can we do that as fast as we can? If I would get such an email, hopefully you would do the same, we'll try to sketch a little bit what do I need to do. I need to gather info about all of those 93 files, which probably will involve metadata. I would need to build some tables, maybe some views, maybe even some integration services packages so I can move my data from point A to point B. And if I were to raise the question back towards you, if you would have 93 differently structured files that you would need to do all of these to get into your database, how much do you think that would take you? Would you see this as a matter of hours, days, maybe even weeks? What do you think? I hear some days in there, maybe some hours. To be fully honest, the answer may vary depending on how many developers you are, what technology you're using. But what would you say if I would tell you that with the help of our colleagues and with a bit of a preparation and hard work from the BI team, we could do this in something like 10 to 20 minutes? Would you be eager to learn more? Did that sparkle some curiosity? Because I hope it did. And in order not to delay things further, I would like to start with gathering the information with open metadata. So I will hand over the stage to Bogdan.
Okay, thanks again, Remus. Let's start with the open metadata and the governance. A couple of ideas about that. First thing first, it's the question, what is metadata? And metadata as a definition is data about data, or I can say information about data. And to give you a small example about what metadata is, it's when you take a picture or photo with your photo camera, that file of the picture, it's data. But the camera can save the picture into a file together with information such date and time where the picture was taken, or maybe the location, if it's activated by a GPS, the location where the picture was taken. Some information about the photo camera or the device, or technical data about the camera can be also saved together with the actual data into that file. And why exactly that's important is because, as an example, later on, based on this metadata, you can build a gallery yourself, or you can use an application that builds a gallery out of these photos based on metadata. So it can arrange the photos chronological based on metadata. Without metadata, it cannot be done, right? And there are other applications that place your photos into a map to remember you where you taken that photos. So basically, this can be done also with metadata. Without metadata, you cannot interpret correctly the data. So when it comes to a larger company such ING, things are much, much complicated than that, much complex than that. It can be relationships between metadata. We can talk about lineage about metadata. We can think of getting the history of metadata into a system. So that's why we build this project, Open Metadata, which basically it's a collection of open source projects, Apache open source projects that incorporates as a core component. It's Apache Atlas. This is a metadata repository. It's based on a GraphDB. In the end, it's a GraphDB that keeps all the relationships between metadata and things like that. But surrounding this core component, we have Apache Ranger that handles the security and rules and policies and enforce securities for the entire system. And we have, for virtual data connector, we have also a virtualization part, which is mainly made by GaianDB, which is a federated database that handles the virtual views for the real data. Yeah? So main things that open metadata is made for are simply like that. You can easily access your metadata spread in various places in your company, because you can have one single search point for the entire system. And of course, you can have a better interpretation of the data because you have governance, you have classification, you can know who's the data owner, what's the purpose of the data, or you can also know how can this data can be used in the end. Yeah, and being an open source project, that's the beauty of open source. It's supposed that you can use your own tools, that you are, no matter the vendor, what the vendor is, you can use your own tools to access the system. You can use your own programs and software you are used to do it. So in essence, open metadata has a common base. It's an open set of it's an open set of APIs, which means basically that being open set, we try to make a standard out of it to expose these standard APIs to the application furthermore. And you have a lot of flexibility in define your metadata types. You can have an open set of metadata types, but you can also define your own metadata types yourself. And of course, we want to have open set of exchange protocol, which means that all the components can communicate one with other in order to have one single point of search, and you can search in one point and you can see that you have some metadata in one repository and others in other repository according to your search. All this plus governance plus self-discovering, because GaiaNDB is a self-discovering system, and access frameworks. All these things are making open metadata. And if you want to look at as layers, basically are two main layers in open metadata. First is open metadata access service. This is these are the services exposed to your own application, if you want, to the UI that comes together with a project, and this is the interface to communicate with the system. And underneath, it's open metadata repository service. This handles the communication with different metadata repositories. Can be Atlas, that it's included in the project, but also can be metadata repository from IBM or from SAS, or doesn't matter basically what is the vendor. To give you a simplified idea about the architecture of the virtual data connector that we want to implement here in ING, you can take a look at these pictures. And what we have, basically, we have data lakes. And in data lakes, we can have different kind of data sources. It can be Oracle, can be MySQL, but data source can be also a REST API or a Kafka topic, can be anything that you can connect to. And in the front of each data source, we can put an GaiaNDB for virtualization in order to access the real data. And what else we have in ING? We have IGC, which itself it's a metadata repository. Basically, it's a catalog from IBM that it's the initial catalog for the data. And all the changes that are made in IGC are published into a Kafka topic, and from Kafka topic are picked up by the IGC event mapper. It's a Java component, and this IGC event mapper basically it maps the messages published by the IGC into OMRS format, and having this, we can have all the data replicated in the Atlas repository. And here the interesting part is we have another component called virtualizer, which picks up the metadata and creates the virtual views based on this metadata. Which means basically, if you do a search, you can search metadata according to a query, and after that you can go to the real data and have a preview of the real data. The upper component, Aperture Engine, as I told you, handles the security enforcement. of the entire system. So it handles the rules and policies of how data, who can access the data, who's the data owner, who can access the data, and according to what rules this data can be accessed. And of course, it has a synchronization with LDAP of the company, from where it takes the users and roles and having this sync and using the governance engine, OMAS. It's one of the OMASs you saw in the previous slide, enforces the security on the entire system. And in the top, we have a virtual data connector UI, which is a UI interface that we are working on to be something like someone called it Google for data, because it has one single search bar and one single search field, and you can search keyword and get to the metadata, and from metadata to the real data. Couple of words of who's involved in the project. There are three main community members. It's us, ING, together with IBM and Hortonworks. IBM is a well-known company. Hortonworks, I don't know if you heard about Hortonworks. It's they handle a distribution of Hadoop in the United States. There are also loosely coupled community members. Oracle is interested, Microsoft is interested. They want to make their products compliant with the open metadata. And as I promised you, I will try to show you, because demo is much better. Hopefully it will work. It depends on the cloud computers that we have. So I will show you. Yeah, I will show you a bit of a demo. All right, let's. Okay. Basically, what I want to show you is, let me. Yeah, this one doesn't work anymore. It's not active. Just a moment. What I'm trying to show you is the part of Apache Ranger that enforce policies for the virtual UI, for the virtual data connector UI to access data into the real data based on the policies and the rules defined on the Apache Ranger. So let's get out of the presentation. Yeah. Okay. This is the UI, and for this demo we have two different users that have two different roles. One user is called Case, and one user is called Marina. This one is Ranger. Let's go to the Ranger again. This is the Ranger interface that provides the security. So in the Ranger, as I show it to you in the slide, we have a Ranger plugin into the Gaian DB, which means the Gaian DB plugin communicates with a Ranger server and applies the policy to when it accesses the real data. So in the Ranger plugin, the Ranger server can handle a variety of other servers, but most important is this one for us, Gaian DB. And in Gaian, we have two different kind of policy. One is access policy and one is masking. And for access policies, by default, Ranger denies access for everything to everybody. And prior of this demo, I have added this allow all policy. Let's take a look a little bit on it. Basically, what this allow all policy says, it says that no matter the schema is, no matter the table is, and no matter the column is, it will allow access to everybody. It has allow conditions and deny conditions, but also can have exclude from allowed condition and exclude from deny condition. So basically, you can have one user that it's excluded, even the roles that the user has is in that policy. And I will show you why I did that. Because let's have case first. Case, it's a user that searches something like first name, let's say, or first. And what the user sees is that first, the term that he searched, is found in 3 tables: emp, salary analysis, contact list, and employee. And of course, in employee, it's the first name of the employee, and in contact list is the first name of the contact. The idea is that the term can be a technical term or a business term associated with that metadata. And if you click on, let's say, first time to the technical term and go to the real data, you can see highlighted the first name as it is in the real data. The real column name is F name, right? And the user search for first name and he get it, the F name. This is the technical perspective. But if you go to, again, to the search and take the business term, which the business term is first underscore name, and click on it and go to the real data. Now the user case can see the business term associated with that column. So basically, if you search for a column, it can be acronyms, can be something like someone decided to say CSTN, which means customer name, but you don't really know what CSTN is. So if you have such a system, you can search for first name and you'll find in the end that column CSTN, and you know that that column keeps the first name of the customer. When it comes to sensitive data, can be search something like annual salary. Annual salary is sensitive data. And of course, we have also business term and technical term. But most important thing is, because of the policy I defined it, the salary and also the bonus, if you want, it can be seen by the user case. And let's go to the masking in the Ranger. And let's try to activate this masking policy that says the name of the policy is hide salary for case. It's disabled. And what this policy says, it says that for the schema Gaian, for the table emp salary analysis, salary, bonus, and location are must. Let's remove bonus and location and stick with the salary. Let's activate it and save it. The propagation may take a while. It's not instant. It's not propagated yet. Oh. Yeah, and now the annual salary is masked for the user case. The Ranger Gaian plugin masks the numeric fields with 4 of 1 and the string type fields with hashes. So basically now the annual salary is masked, and let's try something else. Something like, let's try to add bonus. And even location. All right. Let's see if it propagated. Not yet. I'm not sure if I have to log out for this, but I think not. Yeah. So right now, because of this policy, location is masked, and also the bonus is masked for this user. And if we are going to Marina, and search for annual salary. Oh, sorry. Yeah, Marina is able to see the location, salary, and the bonus. Pretty much that's it. The demo, the UI, it's not that fancy yet. We focused first on the functionality in order to make an idea about how can we apply security, how can we search for the real data based on the metadata, and how can we preview this kind of data. There are plans to have other cool stuff like natural language processing in the future. But for the moment, that's the status. It's a project in development. So for the Q&A session will be after Remus' presentation. Remus will give you now a presentation from the BI perspective of how you can use the metadata, and also a bit of a demo. So, Remus?
Yep. That's good.
Okay, thank you.
Let's get back to the slides first. Give it 2 or 3 seconds. He's a bit shy. Okay, so BI building blocks. I'll try to steer you a little bit back into the BI world, because now we have metadata, we can store it, we have something like a single point of contact where I can just go in there, take my stuff, and do my work. But how does this link with building blocks? Well, if you read the news, if you open the newspapers, who does it these days, you will see that every company says that they're data-driven. And I would like to tell you that we as BI individuals, especially in the ETL, especially when building our reports, we are, or can be, metadata-driven. And this all can happen with building blocks. And you can automate a lot of your stuff if you have a bit of a helping hand from Bogdan. And as a beginning, I tried to sketch a little bit over here how average BI project will look like. Initially, you have some input, and that input can come in the form of cloud sources where you just tap into a database on the cloud, you get your stuff. Or it can be multiple files scattered along multiple hard drives. It can be even users, if you're lucky enough that your users are actually getting data into your databases. And all of this information comes with a lot of data about it. You for sure bumped into file names, column names, data types. And let's be honest, how many times did our ETL crash just because someone changed the comma in there or changed the delimiter, and you have nowhere to pick that up from? And after you load it, then you get it through your databases. You can call them different ways: staging, operational data source, data warehouse, whatever. But I can bet that you're doing some transformation. You're doing some mappings, you're applying some rules. And it would be neat if you could have a place where you can store those rules, because those mean data lineage, a term that also Bogdan mentioned. And a bit of a backside to all of this, something that's hidden in between the scenes. It's all about runtime, batch status, and row count. This can be metadata as well. And I think you're storing it, you're looking at it, especially when something goes wrong in the next morning. So you can call that process-wise metadata. You try to see how much did your job executed, if it's going up in terms of time, if it's going down. Hopefully it stays stable and it doesn't crash, but well, sometimes bad things happen. And at the other side of the BI area, there are cubes, there are dashboards, there are mobile apps, and there you are connected with your users, you're trying to show them something, specifically meaningful information, KPIs, and they would like to steer the business correctly according to that information. And here you're using calculation, you're using definitions, and try and think about how big of a blunder it can be if that person who's looking at your report doesn't quite understand what they're looking at. Think about, I don't know, common field like customer. In a big environment, a big company, there are a lot of source systems, and for them, maybe if you're working for finance, customer is the actual person paying the bills. But for shipping or for logistics, that guy is, well, the address of the person who I needed to ship the goods to. And if you're a bank, you care about risk, you care about what are you financing, maybe you want to see the actual beneficiary at the end. So just by seeing a field customer in there, if you would be one of the CEOs or if you would be in the higher management, that might raise some questions. And you need something like a data dictionary where you can go, check your term, be sure that you name it properly, and be sure that whoever looks at it sees the correct picture. So overall, metadata is kind of everywhere around us and everywhere in our day-to-day work. So if we bump to it with it every day, every hour, how can we make our life a little bit better? And I took the liberty in putting like 4 steps. And I'm going to focus more on the technical part because I'm a BI developer. What can I do? And these 4 steps start first with data, because you are BI experts. I bet you know what you're doing with that data, and you know a lot about it. I bet you have it available because you're loading it probably every night, so you have tons of it. And well, we've been talking to you for about 30 minutes now that you have even more data than you ever thought about. So can you do something with the data? Can you do something with the metadata maybe? And if you have a lot of data, if you have a lot of information, then you can just try and figure out some patterns, either in the data or in your day-to-day work. And again, because I'm a developer, I'm looking at my technical stuff more. So I see that I'm doing a lot of basic SQL statements. I'm writing create table and create view every day. And it kind of looks similar. What changes? Well, like a schema name, table name, column types, maybe some column-friendly names in there, and everything else stays roughly the same. And in the SSIS, integration services, extract, transform, and load, well, I'm doing the same thing. I'm trying to load files. I just change a file name. I just change some columns in there. And for me as a tech guy, it's getting boring doing the same thing every day. So how can I automate that? And that's why the next term is automation. And for SQL, maybe all of you know, I won't get too much into detail. I'll show you a bit in the demo. It's dynamic SQL. If you're writing the same create table 100 times on your development environment, you might as well build some dynamic SQL behind it, click it twice, and hopefully you're done. And the dynamic SQL for integration services in the Microsoft world, it's called BIML. And for the ones who don't know, BIML stands for Business Intelligence Markup Language. And it can help you automate all those nasty ETL packages that you need to do over and over again so that you can load all that data, that you can transfer data from point A to point B. And you're doing all of this, you're automating your stuff, you're creating more time for you, but what are you actually bringing to the story, to your BI team or to the individual sitting right next to you? Well, you're bringing a lot of standardization because it's all about control, it's all about stability, and it's all about knowledge transfer to the person sitting next to you, maybe your colleague. If you have the same framework, if you can build it, if you can apply it, you can just put building blocks on top of each other, and you can have one building block of error handling. You can have one building block for, I don't know, logging what happened to your ETL, and maybe other building blocks that are just standard data flow tasks. So in the end, you gain a lot of time, and if you gain a lot of time throughout this, well, I would say simple process, then you can use that time to look again at the data and go again through the whole exercise and make your life a bit easier. And before I go to the demo, because this is a BI conference, I can't let you get away without a chart, because probably charts and dashboards and KPIs are things you see every day, even today. So even after work, you'll see this one as well. Don't frame it up on the wall. It's not statistical information. It's just estimation from my team and I. But what we try to do here is, what would happen if you would have to build 93 ETL integration services packages? Similar to the example that I had at the beginning. And well, at 93, this is just kind of an abrupt slope. But I put in there 3 possible scenarios. The orange one, you just do it by hand. You start now, you finish in a couple of days, maybe. Hopefully, you're not error prone, because that's going to be a bit of an issue. And you'll see that if I raise the number of packages, I raise the difficulty, I raise the time, and probably I raise your level of boringness. On the gray area, we have a bit of help from Bogdan. What if you don't need to sit in all those calls, trying to find out a single point of contact, trying to find out the data steward who's going to tell you, this file is like that, and this column is like that. Why can't you get it on a plate? Well, if you work at something like Open Metadata, for you as a BI individual, initially, you will have an overhead because you need to automate getting your data from Bogdan's world. As you saw, it's not strictly SQL, so you need to be a bit of thinking behind it. But over time, that saves you more and more. And the radical solution, where you kind of put me and Bogdan in the same place, try and use things like Open Metadata, try and get your data and metadata in one single place as best as you can, but also try and use technologies like BIML. I've written here BIML because I come from a Microsoft stack. I work every day with Microsoft, but other technologies are out there on the market. Try and automate your work. It's going to be a bit more overhead at the beginning. I wouldn't necessarily do it for one single ETL package. I would just let you do it by hand. You're better at that way. But with 10, 15, 93 packages, well, I don't want to kill you, and I don't want to sit here at a demo for the next 10 hours. So I would like to do it in a different way. And I would like to show you right now how we can do it in a different way, because BIML can help you with metadata drive your ETL. Let's get out of the presentation mode, because I hope you're eager to see some code. And again, he's a bit shy. Okay, so before I get to the actual code and actual demo, I put in there on the slides 2 steps, Dynamic SQL and BIML, and I'm going to start a bit with the preparation. And the preparation here is just, I have already 4 databases. Usually how we work, we have different layers. You have a meta area where you would store things coming from Bogdan, things coming from a data steward. You would like to put in there all the data about data and data about your process. You will have an STG, stands for staging, where something to a landing zone, you can just put in there the today's file or today's batch, just to make sure it doesn't ruin your historical. Then in the operational data store, you can just store years of data, tons of it. And in the data warehouse, you can start modeling things up. And you will see that I have the staging area, ODS as well, but I won't open it right now. They're pretty empty. I have nothing, but I still have the example where I need to load a bunch of files. I won't go through 93 files with you, but you will see for the technology at hand, 11, 93, 1,000, it's just a number. I picked just 11 because maybe I'm not that brave. But for these 11, I had to go and gather all the metadata. And what metadata will I need for something like an ETL? Let's see if I can. I think you need a bit of magnifying power in here. I'll just use standard Microsoft stuff. And I have a magnifier in here to help a little bit. And usually, what do you need for if you want to load the file? Usually, I would store like 3 things. I have a file, which is my source, and I need to have some information about it. And you'll see later on the information is it's a text file, is it a CSV, does it have a name? Should have a name, but is it standard? And then I have some staging because I want a table, I want a view in there, and then I have some ODS. And I wish in the future that I wouldn't need to gather all that stuff. I would just phone Bogdan and get an extract of some sort and just load it in here. And again, for a text file, just as a quick walk through what's a text file. It has header and row delimiters, separator, so some identifier. Again, these are those things that crack your code. You're preparing for a text file, and that guy in the business just sends a CSV or just sends an Excel because he can. And then you need to kind of, well, either redo it or change some information. And the other two tables, they're just about column definition. Because if you would like to prepare an ETL and to load some data, you would need to have information about the file. And the information usually comes in the form of data types, lengths, maybe a friendly name in there. I know I didn't pick the best of friendly names, but it's just an example. And if you have all of this, then all you will need is just a column mapping. I will not zoom into it because it's really boring. You just want to take column A from that file and move it into column B or A or whatever into the table. And then just pass it along, maybe even add some transformation in here. But you need all of this. This is all of the data that you're actually doing by hand. And if you have all of this, what's stopping you from creating something like a dynamic SQL? And the dynamic SQL part that I just want to zoom into is the create table area, because I was giving you an example that you're writing create tables. If I would write a create table 11 times right now, we would just sleep here, because I would take a lot to do it, and probably I'm a bit nervous, so I would make some silly mistakes. So why can't you just put like a create table, because that's stable, and get in there a schema name, get in there an object name, get in there all of your column names and column data types. Because if you can just have them on a plate, try and use them. And with this, you can just solve the problem of your tables and views. But I bet you all know this part. So this is rather something that I hope you do at least once a week. But in the integration services part, I bet you're doing it by hand. Probably some of you are using Bibble, some of you not. But I'm going to go through it a little bit. I'll try a more easier example, something to start with. If I would look at a BIML would look like this. And if you look at the code, it's something like a weird mix of XML type of code with some HTML. And if it's, well, similar to HTML, probably it's simple. You need to trust me here. It's not that complicated. And what you can do with it is you can just dynamically create all your integration services. All you need is just a bit of extra stuff in here. And the extra stuff can be some directives with the #@ sign. You can just call for C#. I like C# better than Visual Basic, but you can use Visual Basic as well. And you can include some solution configuration type of file. Because if you have some variables in there, you just don't want to write them every time. But just for you today, I've wrote these 3 variables or these 3 connections in all my packages, because writing them together is going to be boring and I'm lazy. And you can use some variables in here that you have in the solution config, and you put in there the same stuff. You have a server name, it stays the same for probably your entire solution. You have an instance name, that might change, but you can create a variable for it and so on. And if you have all of this, then you can do 2 things. You can have this simple example where you're just creating your containers or your execute statements by hand. And again, it's XML with a bit of HTML combination. You can just create a container. It usually needs a name. Everyone needs a name, even us. And within it, you can put like an execute SQL, again, with the name and a connection. And you can actually write the code in here as well. And you can create another one. I just copy-paste this one and quickly change the store procedure. And you can even put precedence constraints. If you want to run them in a particular order, if you want to have them linear, parallel, whatever output, successful or unsuccessful, you can treat it. You can treat mostly everything that you can drag and drop. You can just do it like this. It's a bit of an overhead. Again, for one package, I wouldn't advise to do it. But for multiple packages, it can be a lifesaver. This is the example of one package. You can just generate the package here. It will start mashing up the machine for a couple of seconds. It asks me if I want to just override the connection. I've already made that just to be sure that it's accurate. And if I would open my one single package, which I'm telling you, don't really do it, but you'll see how I do more in a few seconds, it has exactly what I told him to do previously. Well, it has a container. I just named it sequence container. Had no imagination back then. And it has a create schema, and it has a create table and views. And the only thing that these two execute SQL packages are doing is they're just creating a ton of create table, create views, create store procedure for me. And I will just run it. Hopefully the demo gods are kind with me today. And if I have all my dynamic SQL, I've just put it to work, because in the staging area, now I have, do I still have the magnifier, or I just close it? We can bring it back again, hopefully. Don't try counting them. They're 11 now. They can be, well, poor choice of positioning by me, but I'll fix that in a minute. They're 11 right now. They're have some weird names. They have some different structure in here. And I haven't done only tables. Like I have in the other database, ODS, in here I have 11 views. And in the programmability area, I have store procedures. I'm kind of picky with my names, so they have a bit of a long name with them. But they're just some merge procedures, so I can get my data from point A to point B. If it's new, insert it. If it's existing, update it, things like that. And the cool part is that you can use it with multiple packages, because you can generate some staging information with them. You can generate ODS. You can generate a lot of stuff. And if you were to, well, automate and create 11 packages, don't start writing all those containers. Do something like this. Well, you can put in here bits of code, and this can be C#, this can be Visual Basic. And you can tell it, okay, I have an object that is of type database, and I can store into it a lot of info, like my object name, which is my table name, view name, store procedure name. I can have a file extension. I can have a column delimiter. I can have a lot of info here. And I can just store these in one single table. And I can put this table to work within a simple for each loop. Because what do I need to do? If I have 11 lines in my select, I need to create 11 packages. And those would come with 11 containers and with 11 data flow tasks. So just write them in here. And every time you want to point to that table, you can just use the name of the table. Just name the text file, so I make your life a bit harder. And it starts with 0 because we're in programming, and it will end up until the last column. You have 3 columns, going to be 0, 1, and 2. So you can get to your cell, to your information. You can just paste it in here. And of course, if I want to name something, I want it every time to be named something underscore my table name and so on. And you can be consistent, and you can build frameworks with it. And because I'm running a bit out of time, I will just run these for you and see how things can start to generate in the SSIS package area. Again, it will tell me to override the connections, or connection. And if I open SSIS packages, and if I look in here, there's something like 11, exactly 11. And if I go to ODS, then I can generate packages again. It's kind of the similar structure. What I do in staging is I just take the file, put it into a table. What I do in ODS, I take the table, and with the merge procedure, I just dump it into my data store, because I want to keep it there forever and ever. And these are now 22 packages. They're not really, very complicated ones. They're just for the sake of the demo. If we would open one of these, you will see it's just, for example, staging. It's just I want to truncate my staging table, and I just want to load my file. If I would pick an ODS one, it's even simpler. I just want to execute my merge procedure. But it's building blocks, because I built something simple right now, and maybe my colleagues, or maybe some of you here in the room, tomorrow will start adding a block of logging that says I want to start logging at the beginning, I want to end logging at the end. Or, I don't know, maybe you want to treat error handling in a specific way. And maybe you don't want to do it just for you, you want to do it for the entire room, for your entire team. You just build it once and run it 1,000,000 times. And maybe the tricky question that you're asking right now, he has 22 objects. How will he run them? 44 clicks? Don't like that. Why do I struggle if I can't make a master package that can just run everything for me? And this one created a master package. And here, it's not the most beautiful master package that you will ever see, because they're just all running in parallel. It's just open like crazy. A lot of packages in here. Hopefully, it has enough RAM to open all of them. But it will run them, load my data, and hopefully everything will turn green. And I'll just, I'll leave this run in the background. Hopefully it's green by the end. And because we're a bit running out of time, the first thing that I would like to say to you is that, between doing something 11 times, or 93 times, or 1,000 times, and doing it with a couple of clicks, it's just a bit of a hard work at the beginning, and you just need a bit of imagination. Just try and think about what you're doing, the same thing every day. See how you can make it faster, maybe make it a little bit better, more efficient, and try to help each other out. Like me, from the BI world, I'm trying to get help from Bogdan, and he's also trying to connect with me in the metadata area. And try to use also the internet. Biml, maybe you heard of it or not, but it has a community which is pretty much alive out there. It's made by Varigens. You can just download it for free. So it's a similar free kind of platform. You can just use the code. And if at any point in your life you ever dreamt being a hero, if you plan on doing something really exquisite with Biml, you can just present it online, and you can become a Biml hero. So I advise you to go to the Varigens SharePoint, check the Biml heroes out, and a big shout out for them, because they're online, they will help you, and even I, which I'm not a hero, I'm just an ordinary developer, I will try and help you online if I find your questions out there. And who knows, maybe the next hero will be in this room. And I will just let this run in the background, and I'll put up a thank you slide for the end here, because let's end in orange. I'll try to invite also Bogdan on the stage. I would have two big thank yous. One big thank you is for my team and for Bogdan's team and from everyone at ING Tech, because, you only saw two faces here, but there are people working behind us at projects, there are people helping us build this cool new stuff, and it's not only us. They're working harder than we are. So big thank you to them. And also a big thank you to you, because you've been spending the last 50 minutes with us out of your free time. I hope you enjoyed it. I hoped it was something slightly new or slightly interesting that sparkled a little bit of creativity. And if you ever want to work with Biml or automate stuff, or if you have great ideas, let's talk and let's see. So a big thank you to you for listening to us this evening.